Good morning all. I've been having quite a bit of fun recently, that's when it's not raining of course, flying my quadcopter, but I thought it'd be quite fun to go to the next level now and fix onto it a camera, which is going to be an FPV, a first person view system. So the camera will transmit video and audio down to a small monitor on the ground, and then I can fly the aircraft as though I'm sitting in it. Now, I've already got this camera, which I got from Banggood a while back. It's a wide-angle lens type camera. It's got audio on there as well as video, obviously. This runs off 5 volts, which I discovered when I put 12 volts through the regulator and smoke started coming out, but fortunately it survived that ordeal. And now I've got some other bits from Banggood, including this 5.8 gigahertz audio video transmitter. This is a 10 milliwatt. Now I believe that the UK rules are no more than 25 milliwatts, so this is perfectly legal, so that's good. I've also got some connectors. These are, I think these are reverse SMA. I will have to check. I'll go onto the Banggood website in a minute and show all these bits with the pin in there. I can't remember whether this is reverse male, female, whatever. What else have I got? This 5.8 gigahertz circular polarized antenna set, and you can see in here that there is the TX antenna, which has a slightly shorter wire for whatever reason. It actually says TX on the top, and the receiving antenna, which says RX. These are, they've got the sort of female part in there so that they can be connected to those male connectors that I've got. I'll open these up in a minute because they're very interesting what's inside those. And I've also got this 5.8 gigahertz AV receiver. Now there is one that's slightly cheaper than this, but this one has a nice 2-digit 7-segment display and a button for flicking through the channels. The cheaper one had DIL switches, which I just thought was a cheapness taken too far, so I went for the slightly better model, and that comes with its own 5.8 gigahertz antenna. Now I've been doing a bit of reading about aerials, and I'm trying to decide whether this is a dipole or a monopole, and I still can't quite make up my mind, but it'd be interesting to compare this, I don't know, rubber duck or flexible antenna with the circularly polarized types. So let's look at all the bits together. So here they are, the camera, the transmitter, a little connector there so that I can connect the antennas. Actually, I pledged not to say the word antennas. It's going to be aerials for the plural and antenna for singular, I've decided. So here are the aerials, these circularly polarized ones. We'll come to that more in a minute. And also this whip antenna. So I'll compare which ones work best, and of course the AV receiver. Now if you think you've seen this particular set of parts in another video, well, you may well have seen them in iForce 2D's cheap-ass FPV video, which I'll link up here, because I certainly was, well, let's say inspired by that video to use a very similar set of components to build this FPV system. So let's have a look at this transmitter module first. On the back we've got all the connections. Now there's ground, antenna, ground on these, which is quite convenient because it means I can try and mount this antenna connector directly onto these 3 points. And also because of the way this connector works, I should be able to bridge that across, perhaps if I cut these bits of brass down and also solder it onto the top of the tin can, so that it's resiliently mounted. Channel 3, 2 and 1 are these 3 pins at the bottom here. You can see those root off round to some gubbins inside. They are a binary selection for the transmission channel. I'm not quite sure what the coding is yet. If I leave them all open circuit, I presume they'll drift high, so that out of 8 channels, well, probably will give me channel 8. We'll find out later. Video on this pin here, audio, ground, VCC and ground. Now VCC, I'm pretty certain, is 3 volts. Let's take a look at that on the listing page, Banggood's sales page for this item. So here's the transmitter module. It's a Boscam FPV 5.8 gig 10 milliwatt wireless audio video transmitter, SKU 075325, $8.09. Now further down there is some pin descriptions here, but more importantly there's an application diagram. Now they show the video going through a 470 microfarad capacitor, but I don't think I'm going to bother with that because I think this works without it. Audio goes in directly. VCC up here is 3.3 volts. Well, that's fine because I've got some 3.3 volt regulators here. These are AMS 1117 3.3 volts. So we'll use one of those to get the 3.3 volts. I'm thinking that the input voltage to the system will be 5 volts, and then I'll take that down to 3.3. Smoothing cap there, I may or may not bother with that. Actually, probably have to with a regulator. The antenna will connect onto that. And then you've got these DIL switches, which I'm not going to bother with, because if I just leave them open circuit, I assume they'll float high. We'll get 111, and that is indeed channel 8 on the frequency 5945 megahertz. So these are the connectors. They're now RP, I assume that's reverse polarity SMA female adapter. That seems rather strange because that's got a pin in it, so I'm not quite sure how these are female. I thought that the gender was defined by the actual signal pin itself, but anyway, perhaps these are female. What do I know? I don't know much about RF, I'm afraid. So yeah, you get a pair of these for $2.75, SKU 228961. The Mushroom omni-directional antenna set, $7.32, are these two aerials. Now you've got to be careful to get the right set. So what's this one? This one says it's right angle SMA female. That's where they've put the mark. So let's have a look. RP SMA male. They only seem to have male types. Not sure what that's all about. Well, some confusion here because the box says SMA female, right angle SMA female, SMA male, or right angle SMA male, but the website only has choices of L, which I presume is right angle, male, male, but also these RP versions, so I'm mightily confused. The antennas themselves do appear to be female because there's no pin in there. There's a little, well, not to be too crude, hole. And finally the receiver, which is the Boscam FPV 5.8 gig 8-channel AV Rice Vittori. What is a Rice Vittori wireless? It's the RC805 model, which comes with, let me just click that box down there. It comes with power connector, audio video connectors, and an antenna. Now this receiver is clearly intended to be powered from a 3-cell LiPo, 11.1 volts nominal, more like 12 volts when it's fully charged, because it comes with this cable. So I can either do that, or I could push this a little bit and see if it'll run from lead acid or something along those lines. Now the quadcopter itself has this connector here, which is direct from the 11.1 volts. I think it's just paralleled up with the input connector, and you can see that it's got these kind of curves on the cutout here. So I think it's intended that you put one of these JST power connectors in there, obviously not the battery, but I'll have to get a JST power connector to take 11 volts from the quad. And then my plan is to use a buck converter, something like this. What radio control people will call a UBEC. I think it's a universal battery eliminator circuit, but it's basically just a step down switch mode DC to DC converter. Now I'm going to take the 11 volts, 12 volts and step it down to 5 initially, 5 switch mode, and then linearly take that down to 3 or 3.3. The camera will do that itself because it's got its own regulator. The transmitter will do that courtesy of the little regulator that I'm going to solder onto it. And I think that's probably the best way to do it because we get the energy efficiency of a conversion from 12 volts to 5 using a switch mode converter, and then the nice smoothing effect of the linear converters to take 5 down to 3 or 3.3. Now you can get some very compact versions of this simple step-down regulator. Tiny little ones, about half the size of this. They're very light, so I'll order some of those, but I don't have that at the moment, so I'll probably use this just for the time being. In fact, today I'll probably power the camera and the transmitter from 5 volts just from some nickel metal hydride batteries and not bother with this at all. Now, just before I start soldering things up, let's have a look at these aerials, because these are quite fascinating. Let's pop open the transmitter aerial. Now, this is called a cloverleaf. When I saw it, I thought, well, that's interesting. It's omnidirectional, clearly. But this is a cloverleaf, and the receiver antenna is subtly different. Let's see if I can get the lid off that. So the cloverleaf on the left, the transmitter antenna, is 3-lobe. It is skew planar, but it's generally called a cloverleaf. The one on the right here is the receiving antenna. This is called a skew planar wheel. So it's a wheel-based antenna. If it was completely flat, there is a thing called a big wheel that I looked up, which is an omnidirectional antenna all in one plane. But this one has had its planes all skewed, so it's skew planar. It's a wheel, it's 4-lobe, and the lobes overlap, whereas the 3-lobe cloverleaf, the lobes don't overlap. Now, I don't know anything about RF, so I had to do a lot of reading, even just to find out what these are and what the names are. Cloverleaf, skew planar wheel, really extraordinary names. But it does seem that radio control enthusiasts say that this is the best combination. 3-lobe cloverleaf for the transmitter, 4-lobe skew planar wheel for the receiver. So we're not going to go against best wisdom on this. The Chinese are quite happy to make these if people want them, and that's what they do, and they're not terribly expensive. So let's just go with what we've got. Now I've just cut the pins on this connector down a little bit, and that's so that I can connect or solder those connections directly to the edge of this PCB, while at the same time running the two sort of grounded legs there onto the tin can lid and soldering it up there as well, so that this thing will be nice and rigid. This is exactly what iForce 2D did, so I'm just copying his technique completely. Right, so I've lined everything up in my helping hands here. I'm going to solder the mechanical connections on first, these ground points to the tin can lid of the transmitter with my big soldering iron, and then I'll solder the electrical connections underneath after that. Well, that looks reasonably successful for the mechanical connections. Fortunately, both metals took the solder reasonably well, so now I'm going to flip it over and do the electrical connections. So that's the antenna connector soldered onto the antenna connections on the board and mechanically attached to the top as well, so that's not going anywhere. Now I've also soldered this 3.3 volt regulator onto here. Pin 1 is apparently ground, so that's the end one there. Next one up is VCC, and the middle pin on the regulator is V out. The end pin is V in, so I've bent that up, and I can connect a supply between that bent up pin and the ground point that's sitting immediately below it. And I might also have to put capacitors on here, because regulators really need capacitors. So I'll stick a tantalum capacitor on these two pins here and another one across these two pins here, and I'll stick my 5 volts in there, and 3.3 volts will come out and go into VCC. So that should all work, I think. So here's my completed module. Video on the video connection, audio on the audio input, ground, and then VCC is on the input pin of the regulator. So I'll need to put a little black and red wire across the outer 2 pins of the regulator, and then that's my 5 volt supply. Hook up the antenna and give it a whirl. And here's my finished complete system all lashed up. TV, liquid crystal running off my 12 volt solar. The receiver switched on and set to channel 8 running off a 3-cell LiPo. This is actually the one from the quad at the moment, so I'll have to figure out some other way of powering this when I'm flying the quad. The transmitter is here with its antenna. Camera is perched there. I'm just taking power off this little prototyping board. It's got the Atmel chip in it and the flashing LED, but I'm hoping that won't make too much difference. So let's just switch that on to put 5 volts into the circuit, and on comes the monitor. Let's see if it can see my finger in front of the camera. Yeah, and if I nudge the camera, you can see that the image rotates. So that's all working fine. Now I'm just going to take this flashing LED out because it's a bit distracting and I don't need it. This isn't doing anything, it's just providing power to my transmitter. But yeah, that image is pretty good. If I wiggle the camera around, you can see it's very wide angle fisheye. What can I see there? Oh yeah, my computer monitor with a picture of how to wire up the 3.3 volt regulator, the receiver here, and the LiPo here. Let's have a look at the receiver channel. So that's channel 8. So yeah, that's all working fine. Now this is, the transmitter is completely self-contained. So I'm going to take that outside and see if I can get a signal between the transmitter and the receiver back in here. Well, now I'm holding the transmitter in my hand and getting a little bit of visual feedback there, Doctor Who style, which is quite fun. But let's bring that back so you can see my Nexus 4 camera, which you don't get to see very often. So yeah, that's all working fine. Now what about orientation? If I twist it, this circular polarization of the antennas looks like it's working well, because if I tip the antenna so it's on its side at 45 degrees, we're getting no loss of signal. Okay, let's put this thing by the front door. In fact, it'd be quite fun to film that, so let's do that. The workshop's a bit of a mess. Oh, what's happened there? Something's pulled out. 1 second. Well, what's happened is one of these solid core wires has broken off the regulator, so solid core, not a good idea. I'm going to switch to another idea. Right, my new lash up is this. It's just a 4-way battery holder, so I've got 4.8 volts of nickel metal hydrides there, flexible wires onto my PCB lash up, and now I can carry this with me away. So let's see how far away we can get. Let's put the camera back in front of the TV screen. Okay, it's not quite on axis, but okay, so that's with me nearby. Let's wander off. Workshop's a total mess, as I say. Right, I'm going to have to raise my voice now as I get down into the hall, otherwise you won't hear me. Oh, postman's here. Ooh, what's this? Something from China, I think. So let's go out. Oh, that's the picture on the back of my phone. How weird. So let's go out into the garden and see how far I can walk up the garden. Actually, thinking about it, this has audio. I should be able to switch the audio on. Is the volume not up or something? How do I turn the volume up? Yeah, that's volume. Hello, hello, hello. That's interesting. Should be getting audio. Oh, I haven't plugged the audio cable in around the back. So if I put that into the red... Oh, feedback. So, yeah, now I've got sound. Oh, that's better. Right, I'm taking this outside now. See how far it works. Is that still working? I think it is. Okay. Oh, I can hear static. Yeah, that's breaking up suitably. That's good. Let's go out. Quite significantly. Let's come back. Okay, I'm outside the window now. There's the back of the TV. In fact, I think I'll leave this thing and then I can see if that works. Let's just leave that there. Coming back in. Well, that's interesting. Yeah, that all works quite well.